vector calculus, and this is actually a part of mathematical physics. Direct questions are asked in this in all exams, including IIT-JAM, NET, GATE, and also electromagnetic theory. You can consider this because you need vector calculus, basics of coordinate systems, vector calculus in electromagnetic theory. Okay, so this part is in this way, it has got a two-way importance. So what will be the outline of what I am going to discuss is the first is the concept of vector as a field. Okay, not just as a simple vector, but vector field. So like in vector, you represent it by a straight line, and vector field means the I cap, j cap, and k cap coefficients can be function of x, y, and z. Okay, so they represent a quantity which is in whole of the space. So vector field, concept of vector field, and how they are added, subtracted, and multiplied. To our need of multiplication of vectors, need of addition of vectors, subtraction of vectors. So all those things we have to discuss. And then the coordinate systems. The coordinate systems. What is this? Mainly, we discuss three coordinate system that we actually use in our case at basic level. Rectangular or Cartesian coordinate, and cylindrical and spherical polar. Spherical polar. What happened? आवाज नहीं आ रही क्या?
आ रही है सर।
No, sir, it is clear very well.
अर्धेंदु, what is happening?
सर मेरे तरफ से कोई दिक्कत होगा सर।
देखो जरा एक बार।
यस सर।
बिल्कुल दिखाई नहीं दे रहा क्या?
ना सर दिखाई दे रहा है, बस थोड़ा ब्लर है, हो जाएगा सर, ठीक हो जाएगा।
अच्छा ठीक है। So these three type of, because you know, keeping in mind what type of problems you will be facing in mechanics, classical mechanics, electromagnetic theory, quantum mechanics, some statistical mechanics, you may have some rectangular system, some spherical system, some cylindrical system. So यही सब problem तो आप face करने वाले हो, right? हर question में जो system होगा वो इनमें से किसी एक type का होगा. So that's why you need to know how to write a small volume, how to write a small area, how to integrate. So we have to understand the coordinate system and little bit of vector calculus, in which, you know, like in multiplication we will encounter the dot product and cross product of vectors. And taking this further, we will discuss three theorems which are used in many ways. In EMT especially, they are very, very important. And one of them is Stokes theorem. Stokes theorem, then Gauss divergence theorem, Gauss divergence theorem, and the third one is Green's theorem. They will be very, very important. And other identities which are important, I will discuss because they are used in between in doing problems. Like for example, A cross B cross A cross B cross C. So like these identities are used and some related to uh, curl and gradient. Okay, so I will discuss all that in this other, just write it others. Here I will discuss everything wherever the identities and formulas come. So we will discuss curl and divergence and other formulas, okay, related to this. So this will be the outline of the syllabus. So sometimes doing some calculation in suppose classical mechanics or in electromagnetic theory, you require uh, to know about the coordinate systems. Suppose you want to write some small area in the cylindrical system, so वो पहले से पता होना जरूरी है. And the study of vector calculus and vector field will be twofold. One is that we will do this chapter, okay, we will finish this, but the next iteration will come while doing the electromagnetic theory or while doing the classical mechanics. You have to be very, very aware at that point of time, because जो भी आपने पढ़ा है वो उसके एप्लीकेशन करने का टाइम है. सो कई बार जो हम पढ़ते हैं और जो अप्लाई करते हैं उसमें थोड़ा सा गैप रह जाता है. सो दैट गैप कैन ओनली बी फिल्ड जब आप उतने ही एक्साइटमेंट के साथ, जैसे कहीं वेक्टर का एप्लीकेशन आ गया तो उसको आपको उतने ही एक्साइटमेंट के साथ देखना है, क्लियर करना है. सो रियल अंडरस्टैंडिंग कैन नॉट बी डन while टीचिंग द वेक्टर्स. रियल अंडरस्टैंडिंग कैन ओनली बी डन while applying it. So you will be very, very vigilant and very, very aware, ठीक है ना, while we will be applying these concept actually. Okay,
Yes, sir.
ये बात समझ में आई सबको?
Yes, sir.
Yes, sir.
Okay, so to begin with, if I just take a vector, it is like A, this is a vector quantity, and a vector can be represented by just a line, you know, this length is the magnitude and this head, this is direction. So certain quantities, in certain quantities, you know, both are very, very important. What are the two things that are very important for certain quantities?
Direction and magnitude.
Magnitude and direction.
Direction and magnitude. So that will be known as a vector quantity. So if I just take the Cartesian coordinate system, just a second, कुछ light की problem. Yeah. So if I just take the Cartesian coordinate system initially, जिसके बारे में आपको थोड़ा पता भी है, so it is x, y, and z. All three orthogonal axes are there, and this is called origin, right? So I can represent a vector like this. If this is a point P, so I can represent a vector from origin to this point P. This is called X, Y, and Z. Let us call this vector as A. So the meaning of vector is that we are in a three-dimensional world. So position wise. So this vector means what is its contribution towards X, what is its contribution towards Y, and what is its contribution towards Z. So how we see that? यहाँ से एक perpendicular डालेंगे इस plane में on the XY plane. थोड़ा सा 3D imagine करना पड़ेगा. So this axis is like perpendicular to the board and this is the plane. So we put a perpendicular on this plane and then we put perpendicular on these two axes. This is the perpendicular, right? So what will be this quantity? X. What will be this quantity? Y. And what will be this quantity? Z. So this is the address of this point P. So if you want to reach point P, travel X on the x-axis, then in perpendicular direction travel Y along the y-axis, then perpendicular to both travel Z along the z-axis, and you will reach to this point. So this is the address of this point. So coordinate x comma y comma z means address of this point. So that's why. So this, if I take this vector, its resolution about this can be written as ax. Its resolution about this can be written as ay, and its resolution about z can be written as az. Right? So इस वेक्टर का ये तीनों कंपोनेंट हो गया. So you write it like this: A is equal to ax I cap plus ay j cap plus az k cap. So if it is a simple vector, in the case of this representing a simple vector, ax, ay, az will be the numbers. But in the case of vector field, ax will be function of xyz, ay will be function of xyz, and az will be function of xyz. So like if A represents, for example, electric field also is a vector field. So it will be Ex I cap plus Ey j cap plus Ez k cap. Okay.
Yes, sir.
So Ex will be function of
Yes.
xyz. Ey will be function of
XYZ.
xyz, and Ez will be function of
XYZ.
xyz. Is that okay?
Okay, sir.
So that's why this is called electric field. The field word is used because it is a vector field. Electric field. Okay. Now this system is known as Cartesian coordinate system. This is a vector represented in this Cartesian coordinate system. And if you want to write the magnitude of this vector A magnitude, it will be given by under root of ax square plus ay square plus az square, which is also called three-dimensional Pythagoras theorem. Correct?
Yes, sir.
Is it okay? So पहले तो सबसे पहले किसी वेक्टर का रिप्रेजेंटेशन ही बताना जरूरी था. So this is the representation. And please understand this Cartesian coordinate system or any coordinate system. This is rectangular coordinate system. This point is represented by the planes. So this point is actually intersection of planes. ये क्या है? Intersection of planes है. कैसे? आप यहां से गुजरने वाले 3 परपेंडिकुलर प्लेन बनाओ. एक है AZ, एक AX, which is about x axis. So this point is like this ना, 3D में है ये. And एक y से पास होता हुआ, y पे हर जगह कांस्टेंट. सो एक z पे हर जगह कांस्टेंट, एक x पे हर जगह कांस्टेंट और एक y पे हर जगह कांस्टेंट. तीनों परपेंडिकुलर प्लेन्स बनाओ. वो तीनों जहां इंटरसेक्ट करेंगे, दैट पॉइंट इज पी एक्स कॉमा वाई कॉमा जेड. So what is this point? Please write. The point P is intersection of three planes. Three planes. So like, what is origin? Origin is x is equal to 0 plane, y is equal to 0 plane, and z is equal to. So right, the origin is intersection of x is equal to 0 plane. What is x is equal to 0 plane? Zy
Yes, sir.
plane. What is y is equal to 0 plane? Xz plane. And what is z is equal to 0 plane? Xy plane. So origin is intersection of these three planes. ऐसे ये पॉइंट है वो शिफ्ट हो जाएगा. x is equal to some x, y is equal to some y, and z is equal to some z. इन तीनों का परपेंडिकुलर जहां होगा, that will be the plane. Is that okay?
Yes.
ये समझ आ रहा है भाई?
Yes, sir.
Yes, sir.
एक मैं जस्ट एक फिगर शो करना चाह रहा हूं. जस्ट वेट करना. ये सर इनेबल कर सकते हैं क्या सतीश सर, स्क्रीन शेयरिंग? चलो तब तक होने दो, फिर तब तक मैं आगे पढ़ाता हूँ. ओके, सो आई होप यू अंडरस्टूड दिस. इसी तरह से अब देखो, ये प्लेन वाली बात इज वेरी सिंपल फॉर कार्टेशियन, बट इसी तरह से मैं सिलिंड्रिकल और स्फेरिकल पोलर को भी डिफाइन करूंगा in the same manner. And at least now we know about the Cartesian vector, how it is represented. So its addition is very simple, but we should know it because it is used sometimes. So suppose we have two vectors like this, vector A and vector B. Okay, and you want to add them. So without changing the direction, you bring it like this, A and B, and this will be the addition of the vector C, known as triangle law. क्या कहते हैं इसको? Triangle law. So like vector C will be equal to vector A plus vector B. Correct? So like, suppose you have a 2D plane and a vector like this A, which is 2, 3. This is vector A. Okay. So this is tail to head, two vectors. So like here you see tail to head is equal to tail to head. So here also you have a vector tail to head is equal to tail to head. So A vector will be equal to x is what? 2 times I cap, y is what? 3 times j cap. So this is the vector A, and this is the triangle law. Got it?
Yes, sir.
And if you want to know the magnitude of the vector, what is that? So suppose you have 3 vectors like this, this is A, this is B, and this is C, and this is theta. So sometimes this is required. So what is C square is equal to? A square plus B square minus
2ab cos theta.
2AB cos of theta. Just the magnitude. What is this law known as? Cosine law. Very important. While deriving vector potentials and this and that, multiple expansion, we have to use this. Now you see, if theta becomes 0, suppose theta becomes 180. So how this will become? A and B will be like this, right? Bolo bhai. Yes or no?
Yes, sir.
Yes, sir.
So check what will
Yes, sir.
happen. C square will become A square plus B square plus 2AB, right? So it will become A plus B ka
Whole
whole
square.
square. So C will become A plus B as it should be. And if theta becomes 90, C square becomes,
A square plus B square.
which is Pythagoras theorem. So Pythagoras theorem is just a special
Special
case of this. So addition is clear. So two vectors, if we have, suppose A is equal to AX I cap plus AY j cap plus AZ k cap, and a B vector is BX I cap plus BY j cap plus BZ k cap. Okay. So what is the addition?
AX plus BS I cap plus AY
What
plus
is the
BY.
addition of vectors A plus B? It is very simple. AX plus BX I cap plus AY plus BY j cap plus AZ plus BZ k cap. This is the addition of vectors. Okay. And also, when you have a Cartesian coordinate system, like this, and this is a three-dimensional vector, say A. And this makes angle alpha, beta, and gamma with the x, y, and z axis respectively. So this I am trying to explain you resolution of vectors. How to resolve a vector. Like in 2D, first of all, understand. Suppose you have a vector like this, A vector, and this is theta. So resolution means to know how much of this is in the x direction, how much of this is in the y direction. So you can just make a triangle. This is AX, and by simple trigonometry, it will be A cos theta. This is used 1000 times in physics, right? So जिसके साथ थीटा एंगल बन रहा है, that will be the cos component. अब EMT वगैरह में तो लगातार यूज होता रहता है. And this will be AY, that is A sin theta, and you can shift this vector here because parallel vectors are same in magnitude and direction. This will be AY, correct? This is called resolving the vector, getting the components. So here also in the same way I can resolve. AX will be A cos, बोलो भाई, alpha. AY will be A cos beta, and AZ will be A cos gamma. So cos alpha is AX by A, cos beta is AY by A, and cos gamma is AZ by A. These are called direction cosines. What are they called? Direction cosines. And if you add them, cos square alpha plus cos square beta plus cos square gamma, you get 1. Because this side it will become AX square plus AY square plus AZ square upon A square, which will cancel and it will become equal to 1. बोलो भाई, समझ आ रहा है?
Yes, sir.
So resolution is so important that you should understand it 100%. Suppose this is a vector A. This is theta. This is x-axis, this is y-axis. What is AX?
A sin theta.
A sin theta. Very good. अब EMT में होगा ना कहीं फील्ड ऐसी जा रही होगी and I have to resolve it, right? और AY?
एक और
तो थीटा को बहुत ध्यान से देखना है. In this case, theta was with x-axis. In this case, theta is with this axis. So this angle becomes 90 minus theta, and cos of 90 minus theta is sin theta. So A cos 90 minus theta, which is sin theta. So this axis becomes A cos of 90 minus theta, which is A sin theta. अच्छे से आ रहा है समझ?
Yes, sir.
So resolution will be coming again and again. It will appear again and again, and we have to be very, very comfortable. सबसे पहले focus करो theta किसके साथ angle बना रहा है? Is it x-axis or it is y-axis? And I have told you in 3 dimension also. The direction cosines. Any doubt up to this?
No, sir.
नो सर
These are the just basics, हाँ? But basics आपको पता है ना? Basics पढ़ना बहुत जरूरी है. Last तक आते आते complex में भी
Sir.
कैसे?
सर cos square alpha plus cos square beta ये 1 कैसे हुआ?
ये तुम homework में करो. cos स्क्वायर अल्फा किसके इक्वल होगा?
समझ गया सर।
एंड गेट रेडी फॉर द टेस्ट ऑफ कॉम्प्लेक्स। जो लोग कॉम्प्लेक्स पढ़ रहे हैं उनके लिए बोल रहा हूँ, जो भी पीछे चैप्टर होगा उसके टेस्ट आपको प्रिपेयर करने। नाउ इफ आई जस्ट सी, तो अभी मैं कार्टेशियन के बेसिस पे कुछ कुछ बता रहा हूं एंड देन आई विल एक्सटेंड द आइडिया टू स्फेरिकल, पोलर एंड सिलेंड्रिकल। सो व्हाट इज द पी पॉइंट इन एक्स वाई जेड रिप्रेजेंट्स?
Intersection of planes.
Three planes.
3 planes.
Intersection of 3 planes. Okay. Now, if I check about the multiplication, because of the need, we have two types of multiplications. One is known as dot product. And this is also called scalar product. And another one is called cross product. So if I take a vector in Cartesian, A dot B, it is defined as A B cos of theta. So why we need this? Suppose I have an object and a boy is pulling this with F force at an angle theta, and this toy is moving in the direction along the horizontal, and work is defined as force in the direction of displacement, into displacement. This is how we define the work. So force is F in this direction. In this direction, it is just F cos theta. Resolution लगा दिया मैंने, देख लो यहीं पे लगना शुरू हो गया. Resolution of vector. And this side it will be F sin theta. So now this is the force that is moving it in this direction. So it will be F cos theta into D, and we define it like F dot D. Because of that resolution, we defined it like this, F dot D. So this is the need of dot product. So sometimes we need dot product of the vector because of this definition. And this is defined like this. So if I say I dot I will get 1, and J dot J 1, K dot K 1. These are unit vectors. Unit vector means only magnitude is 1 and direction is along x-axis, along y-axis, and along z-axis. So these are called unit vectors. Like if you define it like this, the coordinates x, y, and z. So unit vectors are in increasing direction of x, in increasing direction of y, and in increasing direction of z. So this side I cap, this side j cap, this side k cap. So I cap is in the direction of, in the increasing direction of x. Bolo. I cap is in
Increasing direction of.
increasing direction of x. J cap is in increasing direction of y, and k cap is in increasing direction of
Z.
z. So when you take I dot I and when you take I dot j or j dot k, because of 90 degree, k dot I, all of them will become equal to 0. Correct? So you can calculate unit vector for any vector. It is simply a vector divided by its magnitude. This will give you unit vector. And A dot B can also be written as AX BX plus AY BY plus AZ BZ. This will be the dot product of the vector. किसी का mic on है? Please off कर लो. So dot product will result into a scalar quantity. This is okay?
Yes, sir.
And if result of product of two quantities is a scalar quantity, that means dot product has been done. Like work is the result of force and displacement. And if the result is a vector quantity, that means क्रॉस प्रोडक्ट हैज बीन डन. सो जहां भी फिजिक्स में डायरेक्शन देखने की बात आती है, इसका मतलब वहां पे हमने क्रॉस प्रोडक्ट किया हुआ है. सो क्रॉस प्रोडक्ट इज ए क्रॉस बी एंड दैट इज ए बी sin theta and a vector, because a cross b is not a scalar quantity, it is a vector quantity. And please, everybody will know this, that to know the direction of a cross b, see this, stretch your finger towards A and close it towards B. This is the direction of A cross B. And B cross A, stretch the finger towards B and close it towards A. So that is B cross A. So that's why you have seen that A cross B is equal to माइक
नहीं, तुम झाड़ू दिए थे क्या उसको? नहीं
माइक
दिया।
ऑफ कर लो भाई, किसका ऑन है?
शिवेश.
शिवेश. So A cross B is equal to minus B cross A. Okay? और ये इसलिए भी है कि साइन ऑफ माइनस थीटा बिकम्स माइनस साइन थीटा. तो जब तुम इस डायरेक्शन में जाते हो, इट इज टेकन थीटा, इस डायरेक्शन में आते हो, इट इज टेकन माइनस थीटा. तो साइन ऑफ माइनस थीटा बिकम्स माइनस साइन थीटा. एंड इन ए क्रॉस बी, प्लीज सी दिस, सपोज यू टेक थ्री वेक्टर्स I, J and K. So if you take I cross J, it will become K. I cross J will become K. So I, J and K, इनकी डायरेक्शन कुछ ऐसे चेंज होगी, like this. I cross J is K, J cross K is I, and K cross I is J. And if you reverse the direction, you get a negative sign. Okay? So like if we have two vectors, I cap and J cap, get the direction I cross J, it will be K. J cross I, it will be minus K. And to get the value of A cross B, we can use this determinant. It is like this, it will be used too much. IJK d by del x, del by del y, del by del z, AX, AY, oh sorry,
Sir, AX, Y, Z, BX.
sorry, just wait. AX, AY, AZ and BX, BY and BZ. So this will be just A cross B, the determinant form. So a physical example to this is torque, angular momentum. Like torque is R cross P. Angular momentum is, what is angular momentum? Linear momentum क्या होता है? M.
Torque
It is not R cross B. Angular
R cross
momentum
F.
R
is
cross
R
F.
Yes, sir.
R cross F. And this is R cross P. ठीक है?
Yes, sir.
So these are the examples where you have a vector quantity which is product of vector quantities. So like you see, इसकी definition कहाँ से आती है? Like you have suppose a body going in this direction with speed say mass m, velocity v, and you are here. You want to see the angular momentum. So angular momentum के लिए this will become the radius. You want to see about this point, right? So this will become angle theta. So L will be R. So the definition of L is कि यहाँ से perpendicular डालो इस पे, line of speed पे, okay? So what, this is R perpendicular. So the definition is L is equal to R perpendicular into momentum P. R perpendicular into momentum, correct? This is the
Yes, sir.
definition. And this R perpendicular will become R, this is theta, this is theta. This will become, R perpendicular will become R sine theta. So that's why this will become R sine theta into MV. So now because of this, we define it as R cross P. So because I see torque mein, it will be force perpendicular. So what is the direction of angular momentum? This is R, this is P. So R cross P towards this. So that means it will be revolving like this, okay? About this point, you can see this is revolving like this. About this point, if you see, okay? अब आगे जाएगा तो किधर होगा? इधर, फिर इधर. तो देखो किस तरफ रिवॉल्व कर रहा है? इस तरफ. तो R cross P, it is revolving in the direction of fingers, you can see. So this is the value of cross product. Okay? ठीक है?
Yes, sir.
तो थोड़े से बेसिक्स से स्टार्ट किए, फिर we will discuss the concept in next class. Okay?
Yes.
Okay, thank you.
Thank you, sir. Oh, thanks. Good night.